Last problem, and then I get to go to sleep. Okay, you are given the state table below and the state assignment D equals 0, 1, E equals 1, 0, F equals 1, 1. Construct the state assigned table assuming D flip-flops, where the state assigned table will have the following headings. So we will have present state, little y2, little y1, next state, capital Y2, capital Y1, and we have two possibilities, W equals 0, W equals 1. And we have output Z. And we're going to have 4 rows. Why 4? Because we have to account for every possible combination of our two flip-flops. So we said D equaled 0, 1. E equals 1, 0. You know what we're missing is 0, 0. D is 0, 1, E is 1, 0, F is 1, 1. So 0, 0 is not one in here, but that is a possibility just in terms of the numbers. So we have to put it in. We have to put in all possibilities. If we have two bits, then that means we'd have 2 to the 2, or 4 different states. If we had 3 bits, we'd have 2 to the 3, or 8 different states. And so the 0, 0 is going to be don't cares. So don't care, don't care, don't care, don't care, don't care. 01 is D, so we want to put 01 wherever we had a D in this table. So that would be right here and right here. And E is 10. So 10, here's an E. And F, looks like I missed a D. So D was 0, 1, and there's a 0, 1 right there. And F is 1, 1. We have 1, 1, 1, 1. And our output is 1, 0, 1. Okay, and then part 2 says derive minimum Boolean expressions. So let's start with y2. And it depends on y2, y1, and w. W can be 0 and 1, y2, y1 can be any of these things, and 0, 0 was our don't care. I'm looking at y2. Y2 is the first column. So the first column here, trying to highlight it, I don't know if you can tell. So y2 is D, the first column D 0, 0, 1, and D 1, 1, 0. This is if W equals 0, this is if W equals 1. So I had don't cares when y2, y1 was 0, 0. When W equals 0, at W1, at 0, 1, I have a 0. At 1, 1, I have a 1. And at 1, 0, I have a 0. And then when w equals 1, I have a 1 for 0, 1. And I have a 1 for 1, 0. And I have a 0 for 1, 1. So I can get this one and that one and this one. So this gets me y2 equals, so this circle at the bottom left is y2 bar w plus this circle that's wrapping around has y1 bar, because y1 is 0 here and here, and w, and this circle up here is y2, y1, and w bar. That doesn't seem right, but y2 bar w, y1 bar w, y2, yep, that is correct. Alright, so now let's do y1. So we have y2, y1, and w, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And again, we have don't cares for the 0, 0. And then y1 is the first column. And I see when w equals 0, they're all 1s. And when w equals 1, the only one that's a 0 is 0, 1. So we have this group of 4 and this group of 4. So y1 equals that top row, which is w bar, or this group of 4 over here, which is y2. And then lastly, we need to get our output. So our output depends just on our input. I'm sorry, our output depends just on our present state, not on our input. So it depends just on y2 and y1. And when y2, y1 are 0, 0, we don't care. When y2, y1 is 0, 1, our output is 1. When it's 1, 1, it's 1. And otherwise it's 0. So that gets us this and this, which would be y2 bar or y1 is our output. That's not correct. Oh, yeah, because we don't need this circle, do we? No. Don't need that circle. We just need this one. And so z equals y1. And that is it.